Welcome back to the Packet Lab. Today we're going to take a look at port security on Cisco switches. Before we get started here, I am going to warn you this is going to be a long lesson. Now you're probably saying to yourself, they're all long. Well, yeah, that's true. This one is going to be long even by my standards. And the reason for that is I want to give you a look at some of the bells and whistles that go along with port security. This video is directed mostly towards CCNA security candidates, so the content in this video is probably going to be above and beyond what is absolutely necessary for that test. But I think that port security is fairly important from a basic layer 2 security standpoint, that you're going to want to understand more than just the theoretical basics. You're going to want to see some of the configurations and some of the bells and whistles, because this is something that in the real world you might have configured in your network, or you might want to configure in your network. So I'm just giving you this caveat because this will be an investment of time that is longer than the usual lessons. You have been warned, so you can stop watching right now if you want to get your day back. Okay, with that said, let's jump into it. And as always, we should start out with a definition of the topic that we're looking at, which is port security. So basically what port security is, it's a method for you to limit access on a per port basis to your layer 2 network. And port security implements two different features to accomplish this. I like to think of it as two different filters. One's a bigger sieve, and then below that is a more refined sieve that you can use if you want to. That analogy sucks, and I suppose I should just get into this and explain it. So at that biggest sieve, the first one is basically just limiting the pure number of MAC addresses, and each device with a network interface card has its own MAC address. That's its hardware address. So if you have a PC plugged into a network port, the NIC on your PC has a MAC address. Same thing with a voice phone. Your VoIP phone would have that. So each MAC address should refer to a distinct piece of hardware. Now there are cases where that's not true, where you might have a VM server, for instance, which has a single NIC but then has multiple MAC addresses assigned to that NIC. What we're going to talk about today is basically access switch security. So that type of stuff, if you've got a VM server, that should be more in your data center or your MDF. I'm talking about end users today. This is where port security is going to come in handy. So if you think about it, most end users only really need one, maybe two MAC addresses per port. One MAC address obviously will be their PC, the NIC of their PC. And then if you're running VoIP, they could have a Cisco IPT phone, and that would be the second MAC address. So in a lot of cases, 98% of your end users, they don't need more than two MAC addresses, and if they have more than two MAC addresses on their port, that sometimes means they're up to monkey business. And what I mean by that is that the devices that would have multiple ports would be devices like a switch or a hub. So what commonly happens in networks is that for any number of reasons, in networks that I work in, we charge back per port cost. So the business unit pays us X amount of dollars per year per port. So it doesn't take long for these guys to figure out that, well, if I'm going to pay X amount of dollars per port, I can save money on that by going out and buying a $20 hub, connecting to that port, and then connecting me and all my neighbors to that hub. Therefore, I've got, just for instance, 8 devices connected to this hub, connected to a single port. So now I'm really only paying 1/8 of what I would pay for normally. So on that switch port, rather than seeing, let's just say we're just going with PCs, we'll take VoIP out of it. Instead of seeing just a single MAC address for the PC, I'm going to see 8 distinct MAC addresses, one for each of these PCs connected to the hub. And in situations like that, not only are they ripping you off for the port charge, but it also incurs additional expenses and time, because if there's a problem, you're going to be troubleshooting your Cisco switch, and in this case I'm assuming you're running Cisco because you're watching Cisco videos, whereas the issue could be that hub. And I've seen this where, oh, I can't get on the network. Well, the port's up, everything looks great, but it's their hub, or their connection from the hub to their PC, blah, blah, blah. Second part with that, and port security really doesn't stop this. There's not many pure hubs out there. They could have a switch which is running spanning tree, and they end up plugging stuff in on 2 different ports, running through the switch, and you get a spanning tree loop, which takes down your entire switch network. So it's a good idea not to let the end users monkey around with network infrastructure. Another situation where you want to limit the number of MAC addresses per port is when a hacker launches a MAC address flooding/overflow attack. I've seen it referred to as both, so that's why I've got the slash in there. In this case, what they're going to do is they're going to hook up their PC to a port, and they're going to run a program that generates random MAC addresses. So by default, Cisco switch ports don't limit the number of MAC addresses that can appear on a single port. So they get these programs, and these programs can generate millions of MAC addresses within, minutes. So what happens is that eventually that switch learns so many MAC addresses that it fills up its CAM table. And the CAM table is the table that assigns MAC addresses to ports. And each switch has a finite amount of memory for that CAM table. The higher end switches obviously have more memory and can keep more addresses, and the lower end obviously just the opposite. But what happens with any of these switches is once that CAM table is filled, the switch is going to act like a hub. So any new traffic that comes in a port is going to be treated like a hub, which is basically going to send it out every single port except the one that it was received on. So with this type of attack, what eventually happens is that your switch becomes a hub, and the hacker plugs into another port with a packet capture program, captures packets from all the users because everything's getting repeated out every single switch port, and then he can analyze that to his heart's content. And it's safeguarding against that type of attack that I think makes port security really, though it's not mandatory, highly suggested that you configure this. I mean, even if you just take an arbitrary high number and say, hey, I'm going to limit every user port to 100 MAC addresses, then that's not going to inconvenience your end users. It's not going to stop hubs and switches, but what it will stop is it will stop MAC address flooding attacks. So restricting the number of MAC addresses per port is the first filter. That's the bigger filter. Yeah, I don't like this analogy, but I can't think of a better one at this moment. So the second filter, which is more fine, is that you can go ahead on a switch port and you can define which specific MAC addresses are allowed on that switch port. So you can say to your end user, Joe Blow end user, say, hey Joe Blow, you can plug in the PC with the MAC address of X. Now I know that X isn't a valid MAC address, but this is just for example. You can plug in your PC with the MAC address of X into port fast Ethernet 0/11 on my Cisco 3550 switch. That's the only port that you can use. If you plug your PC into a different port on that switch, you're not getting on the network. And you can see that using port security in this fashion, you can really tie down your network access. You can say certain MAC addresses only can connect to certain ports. That said, if that's what you're looking for, I would suggest probably at least taking a peep at 802.1x. It's commonly referred to as .1x. That's going to give you a far more feature-rich way to implement that type of security. It's a lot more setup. You're going to need servers, blah, blah, blah. I'm not going to get into the details of .1x, but it might be a better solution than going and tying down access to your network on a port-by-port basis. Okay, harkening back to my crappy analogy, this is the first broader filter that you can configure with port security, and that's configuring the maximum number of MAC addresses allowed per port. And remember, this does a couple of things. It will limit the ability of hackers to launch a MAC address flooding attack against your switches, and also you can use it to seek out rogue switches and hubs, because normally they're going to have more than one or two MAC addresses on there. But the MAC address flooding attack is probably the bigger reason to have this configured. And the configuration is pretty straightforward. As with all of the port security features, you have to do this on a port by port basis. There's no global configuration command to enable this. So you go under the interface, in this case fast Ethernet 0/1, and then you're going to enable port security with the switch port security command, and then after that you can set the maximum number of MAC addresses allowed on that port. And you can see the maximum number of MAC addresses ranges from 1, which is a default, to 5,120, and this number could be higher or lower depending on your platform / iOS version. I'm doing this on a 3550 running 12.2.25 code, I believe. In this case we want to set the maximum number of MAC addresses on this port to 3, and the smart ass in each of you is probably going, oh, can I set this to 0 and just basically disable port security after enabling port security? No, you have to have at least 1, again, which is a default, but I like the way you think. Anyways, here's the verification command. We'll touch more on this in another slide, but basically you issue this command, and then port security, you want to make sure that it's up, and then you can see down here, here's what you're looking for, the maximum number of MAC addresses. So we've changed it from the default of 1 to 3.